show you just a little bit of the website for Matplotlib. Control over almost every aspect of a figure or plot, and it's designed to have a very similar feel to MATLAB, which is another programming language, and its own graphical plotting capabilities. Matplotlib works very well with pandas and NumPy arrays, which is why we're going to learn about it. Later on, we're going to learn about some other libraries, such as Seaborn, that is actually built off of Matplotlib. But in order to understand those libraries, it's important to understand Matplotlib first. You'll need to install it with either pip or conda at your command line or terminal with one of the following commands. If you're using the Anaconda distribution of Python, a simple conda install matplotlib at your command line or terminal should install matplotlib for you. Or if you're using another version of Python, pip install matplotlib should also work for you. Now let's go ahead and get a quick tour of the official website. Okay, here I am at matplotlib.org, which is the official website for Matplotlib. You'll see here there's some introduction information. This $75.10. Okay, coming up next, what is the email of the person with the following credit card number? Information, as well as some more official installation instructions and some other documentation links. Probably the most important link on this page, however, is right here under Gallery. If you click on Gallery, or go to matplotlib.org/gallery, you'll get taken to this link, and you should see a list of a bunch of different types of plot names, and if you keep scrolling down, you'll see that there's a bunch of figures or example figures, and these are all the various types of plots that Matplotlib is capable of creating for you. Later on, we'll learn how to use other libraries that are better for things such as statistical plots, but if you ever find yourself having a question of Matplotlib's capabilities, you can come to this page and search for the kind of plot you're looking for. For example, if I go ahead and scroll back up here, let's say you wanted to make a pie chart. Well, you would come here under the gallery, look for where it says pie charts, click here, pie and polar charts, they'll come down to this link, and then it'll show you some couple of figures here that are hopefully relevant examples. Once you find one that looks like what you want to do, let's go ahead and click this first one. It will take you to an example page that not only has the figure, but also has very well commented code and instructions on how to perform whatever plot you're looking for. In this case, a pie chart. Alright, so that's probably the most helpful page on Matplotlib. The other links are just basic links to the documentation and functions in it. And we're going to go over the most common functions as we continue on throughout this section of the course. Alright, remember that matplotlib.org is a resource for you, especially the gallery page. Coming up next, we're going to show you how to actually use Matplotlib to create your own figures. Thanks everyone, and I'll see you at the next lecture. Let's go ahead and get started with Matplotlib. Once you've installed Matplotlib, the first thing you're going to be able to do is say import matplotlib.pyplot as PLT. And then if you're using the Jupyter Notebook, what you're going to have to do is say %matplotlib space inline. And that's going to allow you to actually see the plots you create inside the Jupyter Notebook. Let's go ahead and run this. Great. If you are not using the Jupyter Notebook system, what you're going to go ahead and do is at the end of all your commands for plotting, which we'll show later, what you will type is plt.show, close parentheses. And later on, when we actually start plotting some examples, I'll show you where to actually put that into your code. All right, let's go ahead and walk through a very simple example using two NumPy arrays. I'm going to go ahead and say import numpy as np, and say x is equal to np linspace, so it's going to be linearly spaced. We'll go from 0 to 5 and grab 11 points. And then y is going to be equal to x to the power of 2. So if we take a look at x and y, we have an array from 0 to 5, and then y are just all those elements squared. Now, basic matplotlib commands allow you to very quickly create a plot, and we'll show you two ways of creating matplotlib plots. One is a functional method, and the other one is the object-oriented method. We'll show you the functional method first, and then we'll shift over to the object-oriented method, since that's usually the better way of creating a matplotlib plot. Let's go ahead and show you the functional method first. The functional method is actually quite simple. You say plt.plot, and then we can do shift-tab here, and you're going to pass in several arguments. First one you're going to do for just a basic plot is pass in your x and your y elements, and then we can go ahead and do shift-enter. And here, this will actually show the plot. We've went ahead and plotted x versus y. If you're not in the Jupyter Notebook, which you are going to do at the end of this line, before you run your code, is say plt show. And then if I run that, we can see we get the same plot. You don't have to use plt show unless you're using something that's not the Jupyter Notebook. The difference in the Jupyter Notebook is essentially like you're printing the plot. Notice here, if I don't have plt.show, I get an out cell. If I remove this, or actually put it back in, then I don't get the out cell. That's essentially the same thing, just to do a quick analogy, as typing a string versus saying print the string. And that's the exact same thing what plt.show is doing. It's essentially printing out this plot instead of just showing the plot. All right. For now on, we won't actually concern ourselves with consistently typing plt.show. However, if you're not using Jupyter Notebook, you will have to keep typing that. Now, basic matplotlib commands allow you to very quickly create a plot, and we'll show you two ways of creating matplotlib plots. One is a functional method, and the other one is the object-oriented method. We'll show you the functional method first, and then we'll shift over to the object-oriented method, since that's usually the better way of creating a matplotlib plot. Let's go ahead and show you the functional method first. The functional method is actually quite simple. You say plt.plot, and then we can do shift-tab here, and you're going to pass in several arguments. First one you're going to do for just a basic plot is pass in your x and your y elements, and then we can go ahead and do shift-enter. And here, this will actually show the plot. We've went ahead and plotted x versus y. If you're not in the Jupyter Notebook, which you are going to do at the end of this line, before you run your code, is say plt show. And then if I run that, you can see we get the same plot. You don't have to use plt show unless you're using something that's not the Jupyter Notebook. The difference in the Jupyter Notebook is essentially like you're printing the plot. Notice here, if I don't have plt.show, I get an out cell. If I remove this, or actually put it back in, then I don't get the out cell. That's essentially the same thing, just to do a quick analogy, as typing a string versus saying print the string. And that's the exact same thing what plt.show is doing. It's essentially printing out this plot instead of just showing the plot. All right. For now on, we won't actually concern ourselves with consistently typing plt.show. However, if you're not using Jupyter Notebook, you will have to keep typing that. So just keep that in mind. All right, so that's the most basic way to plot something in matplotlib, which isn't so bad. You can actually add matlab-like arguments, such as color and line style, and that will allow you to continue to edit this plot. We'll talk a lot more about this later on as far as line styles and color styles, but if you're familiar with MATLAB, this probably already seems familiar to you. Let's go ahead and remove that for now and just go with the basics. If we want to add an x label, y label, or a title to this plot, we can do that with the following methods. We can say plt, x label, and then just pass in a string you want for the x label. We'll go ahead and say x label, and then for the y label, you can say plt.ylabel, pass in a string y label, and then for the title, you can say plt.title, and then we'll just go ahead and put in a title string there. Let's go ahead and run this, and now we can see we have an x label, a y label, and a title. And later on, we're going to learn how we can specify the DPI, or dots per inch, in order to get some more clarity here, such as a finer font. Let's go ahead and continue on with creating multi-plots on the same canvas. I'm going to go ahead and scroll down here, remove this cell, and talk about putting multi-plots on the same canvas. In order to do that, we're going to say plt.subplot. And subplot takes in a couple arguments as well. Right now we can't see them, so I'll go ahead and tell you. The first one is going to be the number of rows, the number of columns, and then the plot number you're referring to. In this case, we'll just go ahead and say 1. Then we'll go ahead and plot something on that cell. We'll say xy, and we'll go ahead and specify that it's the color red with the string r as a third argument. And again, don't worry too much about fully understanding this, because once we get to the object-oriented method, a lot of this is going to make way more sense. But I just want to show you what's possible for now. And let's go ahead and say another plt.subplot. We specify 1 row by 2 columns, and the third argument is the plot number. Now we're going to edit the second plot, and we'll say plt.plot. We'll go ahead and do y versus x, and specify b for blue as a string here. Let's go ahead and run this and see what we get. Okay, so now we have 2 subplots here. That's creating multiple plots on the same canvas. Now what we're going to do is, after we've seen the very basics of creating a plot, we're going to break this all down for a more formal introduction to Matplotlib's object-oriented API method. And this means we're going to instantiate figure objects and then call methods or attributes from that object. And that's going to be a much better way of actually using Matplotlib. So the basics for now are just using plt.plot and then putting in your data. Or plt.subplot, specifying the number of rows and columns, and then the figure you're working on, and then using plt.plot. Let's go ahead and switch gears to the object-oriented method. And this is going to be much better. The main idea in using the more formal object-oriented method is to create figure objects and then just call methods off of this. So let me go ahead and show you what I mean by that. I'm going to go ahead and say fig is equal to plt.figure. And I'm going to go ahead and close the parentheses there. Now, if I just run that cell, notice I have a figure object has been created. This figure object, you can think of it as just kind of this imaginary blank canvas, and we can add a set of axes to this canvas. So in the same cell, I'm going to say axis is equal to fig.add underscore axes, and I'm going to add a set of axes. And the way you can add a set of axes is by passing in a list. And the list takes in 4 arguments, a left, bottom, width, and height argument that range from 0 to 1, basically the percent of that blank canvas you want to go ahead and take. Let me go ahead and show you an example. And again, I'm kind of going to be showing you a lot of stuff that won't make sense at first, but everything will make sense at the end as you see repeated examples and you break it down further. So I'm just typing in some numbers here. This is going to be the left of the axes, this is going to be the bottom of the axes, and this is going to be the width and the height of the axes, 0.8. Let me go ahead and run this on the cell. And now notice what I get here. Now I have a blank set of axes. So I said plt.figure created a figure object, and then off that figure object, I called the method add a set of axes and passed in a list of where I actually want the axes to be placed. Next, what I'm going to do is actually plot on that set of axes. And this is going to feel familiar to what we just did earlier. You're going to say axes.plot, and let's go ahead and plot x and y on that set of axes, and then do shift enter. And now you can see we've basically come up with the same plot we did earlier, except using an object-oriented method. So if I scroll back up here, this was the plot we did earlier, where we just said plt.plot, but now using this sort of object-oriented method, we're going to have a lot more control over this. It's a little more involved as far as the steps we need to take, but it's definitely worth it. So we've created a figure, we called the figure method add axes on this, passed in a list of axes, and then plotted on that set of axes. If we want to continue by putting x labels, y labels, and titles, we can go ahead and do that on that set of axes. We can say set underscore x label. It's a little different from the PLT, which is just x label. When you're working with this axes object, you're going to have to say set underscore, and now we can go ahead and pass in the string x label. And you're going to do the same thing for y labels. Oops, y label. And let's go ahead and do the same thing for a title. Set underscore title. Now if we run this, we should see our new labels, x label, y label, and set title. Let's go ahead and continue this idea of object-oriented programming with matplotlib by putting in two sets of figures on one canvas. And this will start to make sense as far as what this list is referencing. I'm going to go ahead and scroll down to a new cell. I'm going to zoom in a little bit just so we can get a very clear picture of what we're actually doing here. I'm going to say fig is equal to plt.figure. So I'm creating that figure object. So there's my figure object. I'm going to say axes1 is equal to fig.addAxes. I'm going to go ahead and set main axes. They will be 0, 0.1, 0.1, and then 0.8, 0.8. Again, this is the left, the bottom, and then the width and height of that set of axes. And then I'm going to add another set of axes. Call them axes2. I'm going to say fig.add underscore axes. And then what I'm going to go ahead and do is basically put an insert axes. I'm going to say the bottom of the set of axes starts 20% from the left, 50% from the bottom. So excuse me here. I'm talking about basically this bottom corner of the axes, this left and the bottom. So 20% in from the left, 50% up from the bottom. And then we will say it takes up 40% of the canvas size and width, and 30% of the canvas size and height. So all these values here must be between 0 and 1. Let's go ahead and run this, and note what we get out. We get out this basically insert set of axes. And hopefully now you can begin to see what these values actually correspond to. What I want you to do now is go ahead and pause the video and play around with these numbers, make sure they're all either between 0 and 1, and see how they correlate with this set of axes. Go ahead and just play around with axes 2 and move it around. For instance, try to get this set of axes 2 over here at this bottom corner. Go ahead and pause the video, see if you can move this insert over to the bottom corner. All right, I'm going to see if I can do that now. So if I want this at the bottom corner, I probably want to say that it goes left, bottom, width, and height. So I will try shifting it down by making this basically just 0. So start, well, let's go ahead and say 0.1 here. Start at 0.15, just a little off the bottom of this insert here, or of axis 1. We'll go ahead and run this. And there I was able to move it more towards the bottom. Remember, this second one's the bottom. And now we want to move it more towards the right, which means from the left, I'll want it to, percent-wise, move this bottom corner more over from the left. Let's go ahead and set this as 8. And now it looks like I shifted it a little too much, so let's go ahead and shift it back to maybe 0.5. And there we can see we have it now in the bottom. All right, go ahead and play around with that if these figures or these numbers are still a little unclear. Remember, they're basically just denoting the left, bottom, and the width and height from range 0 to 1 in relation to the blank canvas. I'm going to go ahead and reset these to what we had them at originally, 0.2 and 0.5. So we have our little insert there. And then what I'm going to do is go ahead and plot on these axes. So I'm going to say axes1 dot plot, and I will say x comma y. And then I will say axes2 dot plot, and we'll go ahead and say y comma x. And let's go ahead and run this. And here I can see now I have my little insert and my outer plot. And then I can keep adding stuff on each set of axes. So if I want my insert to have a title, for instance, that's axes2, I can say axes2 dot set title, and we'll go ahead and say insert. Well, let's go ahead and make it very clear. We'll say smaller plot. And then on axes1, let's go ahead and set a title. And we will set this title as larger plot. Let's go ahead and run that. So notice what happened here. That's essentially just an empty canvas. So let me go ahead and show that one more time just by putting this in a cell by itself. We create this empty figure, there's nothing to show, and then you add a set of axes to it by saying axes, whatever, 1 or 2, etc., equals fig.add underscore axes, and you pass in this list that goes from left, bottom, and then the width and plot, or plt.subplot. But we're going to learn how to create subplots using this object-oriented method, which is going to be a lot more efficient and grant us a lot more control. Okay. Go ahead and review this section of the Matplotlib Concepts Lecture Notebook. There's a lot more notes and a lot more comments in the notebook in case any of this confused you, but hopefully by now you have a full understanding of basically these lines of code right here. If you understand what's going on in this cell, then you're pretty much good to go. We just create a figure, we add an axis to that figure, you define the location of that set of axes with this list, and then you can plot on that set of axes, you can set the title, set the x label, y label, etc. Alright, thanks everyone, and I will see you at the next lecture where we're going to continue this discussion off of the same Jupyter Notebook. Thanks, and I'll see you at the next lecture. Hello everyone, and welcome to the Matplotlib Part 2 lecture series. We're going to pick up right where we left off in Part 1, where we learned about functional programming with Matplotlib, and more importantly, the object-oriented methods with Matplotlib. Let's go ahead and jump back to the Jupyter Notebook to get started. Okay, here I'm back at the Jupyter Notebook. Remember from last time we learned how to use plt.figure and then fig.addAxis and then axes.plot in order to plot onto an object-oriented figure using Matplotlib. The next thing we're going to do is learn how to create subplots using the same object-oriented programming method. I'm going to go ahead and say here, let's just clear everything in this cell, and we're going to go ahead and say this. And move the cell to the center, and we'll say fig, comma, axes is equal to plt, and instead of calling figure now, since we're going to try to do subplots, we're going to say subplots. So plt.subplots. Let's go ahead and run this. And notice here we get subplots, just out. Now what I can do is just use the axes object like I've done before to plot on it. And this is essentially no different than what we were doing before. And here we said axes.plot x, y. Where subplots differs is where you can specify the number of rows and columns. For instance, I can say n rows as my first argument is equal to 1, and n calls as my second argument is equal to 2. And I'm going to go ahead and just show you what that looks like. I'm going to hashtag that out and run this. And now you can see I have one row with 2 columns, and that's basically just a nice front handle on calling plt.figure. All subplots is doing is essentially calling these fig.addAxes automatically for you based off of these arguments of n rows or n columns. Let's go ahead and play around with this. Let's go show one more example. 3 rows by, let's go ahead and say 3 columns. And we can see now we have 3 rows by 3 columns. Later on we'll see how to deal with the issue of stuff overlapping, but it's essentially just a one-line call. We just say plt.tightLayout, and that actually ends up fixing those overlaps. But let's go ahead and take a step back and just work with this 1 by 2. Alright, we have plt.subplots, and essentially it's just an axes manager on top of plt.figure. Something to note here is that instead of just saying fig equals plt.figure, I am doing some tuple unpacking. I'm saying fig, axes is equal to plt.subplots. And the thing to note about this axes object is if I go down here to this cell and type in axes, axes is actually just an array of matplotlib axes. Essentially, it's just a list of these axes objects, meaning I can actually iterate through it. I can say something like this. For current underscore, ax in axes, axes.plot, x, y. And I don't actually want to say axes.plot, I want to say current ax.plot. And then we see how we've actually plotted through this axes. Again, this is just to show that this axes object is essentially just a list of matplotlib axes, which are the ones that you manually created when you said fig.add_axes. Just further driving the point home that the only difference between plt.subplots and just doing plt.figure is that plt.subplots is essentially doing this add_axes stuff for you automatically based off of how many rows and columns you want. Okay, since we can iterate through this axes object, we can actually also index it, meaning I can say axes 0.plot x, y. And here I've plotted on this first axes, and I can do the same thing for the second one. I can say axes 1.plot y, x. And here we've seen how to either index call off of this axes array or iterate through this axes array. And just like we saw earlier, we can also call titles and labels off of this. So I can say something like axes 0.setTitle, we'll say first plot, and then I will say axes 1.set_title, second plot. And here we're able to call titles. And you can say set x label, set y label off of either of these axes objects. All you're doing is just actually grabbing that axes subplot object based off of its position in the array. All right, let's do a quick review of these two object-oriented methods. This first method is a little more manual. It's plt.figure. You go ahead and create that figure. You manually add the axes and choose its location and size. And then, based off of the axes, you go ahead and say .plot and .setTitle, set x label, set y label, etc., which we show examples up here. The second method is for subplots that you want arranged by rows and columns. This allows you to call fig, axes, so tuple unpacking here, is equal to the subplots call. And then, based off of those axes, you get an array of axes, and you can plot and set titles either by indexing or by iterating through that axes object. And if you ever have any issues with things overlapping, you can always just say plt.tightLayout, close parentheses, and this will take care of any overlapping plots. I recommend that you just always put this at the end of your plot statements. Okay, now let's start talking about figure size, aspect ratio, and DPI. Matplotlib allows you to control each of these aspects, and you can specify them when you're calling the figure object. Let me go ahead and show you an example. I'm going to say fig equals plt.figure, and the arguments I can pass in are fig size is equal to, and then you pass in a tuple, where the tuple is the width and height of the figure in inches. For instance, I can go ahead and say 3 by 2, and then a second argument you can add is DPI. For instance, 100 DPI, where DPI is just the dots per inch or pixels per inch. I usually just use the default DPI when I'm working with the Jupyter Notebook, so I'm going to go ahead and just clear that for now. I'm going to add a set of axes to this. We'll call it just ax, and we'll say fig.add_axes, and we'll say 0.0, 1.1. And then I'm going to go ahead and say ax.plot x, y. Alright, so there's our plot. Let's go ahead and mess around with the figure size. Let's say we wanted this to be very wide. I could go ahead and say 8 by 2, and now I have this to be 8 inches by 2 inches. Alright, so you can do the same thing with subplots. So I could say plt.subplots, set that fig size. Remember here, now we're going to say fig axes, and I'm going to go ahead and remove the add axes, set the figure size, and set axes. We'll go ahead and plot onto the first axes. I'm going to just say axes.plot x, y, and I get a very similar plot. Now I'm going to go ahead and specify some rows and columns for this subplot. We'll say n rows is equal to 1. Let's actually make 2 rows since we're going wide here. And then let's say we have 1 column. So n calls is equal to 1. Now I'm going to call 0 here, plot x, y, and then we'll say axes 1.plot y, x. And here we can see the fig size has taken this into account as far as 2 rows by 1 column. And as always, since we have a little bit of overlap here, you should try saying plt.tightLayout. And this will attempt its best to fix out the tight layout. And it looks like it did a pretty good job here. There's some issues here with this y-axis, but we'll show you later how you can customize this y-axis to show a little less information. Alright, now that we've finished discussing figure size and DPI, let's go ahead and make a new cell and begin discussing how to actually save a figure. In order to save a figure, you can use matplotlib to generate just high-quality outputs in a number of formats, including PNG, JPEG, EPS, SVG, PGF, and PDF. To save a figure to a file, you can use the savefig method. So for instance, we have our figure here that we already created. Remember, that's just right here, fig. And then I can say fig.save save, fig, and all you have to do is pass in the file name you want. So for instance, my underscore picture, and then you pass in the extension, and matplotlib is smart enough to know what you want. So if you want a PNG, you just say .png. If you want a JPEG, you say .jpeg, .jpg, etc. Let's go ahead and save this as .png, and that will automatically save the figure. Here you can also specify the DPI. So if you forgot to specify the DPI over here when you're actually creating the plot, you can specify again the DPI over here. So you can do this with like a 200 DPI. Then you can increase the DPI as you want more detail. All right, we've already gone over figure titles and axes labels, such as set the X label and set the Y label, but let's show you a quick reminder of how to do that. I'm going to change this back to just a simple fig equals plt.figure. We'll go ahead and add a set of axes to this. So we'll say fig.add_axes. We'll put them at 0, 0, 1, 1, and then we'll say x.plot x, y. All right, so as a reminder, if you want to add a title, you take one of these axes and you say set title, and you just pass in a string of the title you want. In order to set a Y label, you just say set Y label, pass in a string of the Y label you want, and then for X label, you can do the same thing. Set the X label you want. Okay, so I have my title, my Y label, and my X label. Let's talk about legends. With legends, you can use label text to actually clarify what plot is what plot. And I'll show you what I mean by that. I'm going to go ahead and remove these 3 lines of code and say x.plot y, x. So notice I'm just doing this on the same figure, meaning if I say and actually run this, I will get 2 lines here. I will get the xy plot and the yx plot. Since these are quite different, let's go ahead and get something that's a little more similar. I'm going to go ahead and plot x versus x squared and x versus x cubed. All right, so now we have 2 lines here, and if you were just looking at this figure by itself without being able to reference the code, you're probably a little confused as to what each plot represents. You would want to add in a legend. And in order to add in a legend, it's actually quite simple, but it's a 2-step process. The first step is to just call ax.legend at the bottom of your code where your axes are defined. And if you run that, you will notice you get a warning. It says no labeled objects found. And that's where the second step comes in. For each of these plot calls that you just made, you're going to add in an argument called label. And this label is just a string that you want for the ax.legend function to be able to reference. Let's go ahead and show you what I mean by that. We can go ahead and say x squared here as our label. And then in this label, I'm going to go ahead and say x cubed. And now when I run this with ax.legend, I see I've been able to create a legend. So all this does when you call ax.legend is it looks for each of the plot calls and then checks to see if there's a label. And then this label, which is just a string, gets returned and gets matched up to the correct color of your line. And later on, we'll show you how to actually customize your line colors. Now, a quick note is that notice how some of this legend overlaps the actual plot. What you can do in the ax.legend call in order to avoid this is specify LOC. Now, there are actually quite a few locations you can specify, and I'll show you the documentation page real quick for it. It's linked in your notebook in this section. Let me go ahead and go to that link. So that link will take you to a page that looks like this, and you can click legend, and there's basically a set of parameters here. And there's a location code and a location string. So you can specify the best upper right, upper left, lower left, etc. based off the location code. I would always recommend that you just use location code 0 because that allows matplotlib to try to choose the best location for your legend. Let's go ahead and do that. We'll go ahead and say LOC equals 0, plot that out, and we see that the best location is over here in the top left. Let's go ahead and check out one more location code. If we go back here, for instance, if we wanted it in the center, we can specify location code 10. And here we have it in the center. Now, if none of these options are working for you, such as 0 through 10, what you can do is you can also specify a 2-tuple giving the x and y of the lower left corner of the legend. So for instance, we can go ahead and say something like this, 0.1, 0.1. And that means just like you did earlier when you're putting in an insert plot, you can put in a tuple here specifying the location of where you want your legend, bottom corner to be. All right, that's it for this second part. Coming up next on this last part of the Matplotlib concepts lecture, we're going to talk about setting colors, line widths, and line types, as well as working with markers, setting the plot range, and then we'll begin to talk about some special plot types, but that will lead us more into our discussion of Seaborn. All right, thanks everyone. Go ahead and post any questions you have to the Q&A forums, and I'll be happy to answer them there. And remember to reference the notebooks for this lecture. Okay, I'll see you at the next lecture. Hello everyone, and welcome to part 3 of the Matplotlib lecture series. In this final part, we're going to talk about setting colors, line widths, line types, and really customizing the options of how your plot actually looks. Let's go ahead and jump to the Jupyter Notebook to get started. Okay, here we are at the Jupyter Notebook. Let's go ahead and talk about setting colors with Matplotlib. So I'm going to go ahead and just say for green, and you get a green line. So very basic color names, it can actually accept as a string. If you want to start getting more detailed, you can actually put in RGB hex codes. So I can put in hashtag and then some RGB hex codes, such as, let's go ahead and just copy this from the notebook, FF8C00. Easily plot them and just pass in the string. Equals 20, that's 20 times the thickness of the default line. Or if you want a very thin line, such as half the default thickness, 0.5, you can start getting thinner and thinner. Another very useful tip as far as line width and line visibility is the alpha argument. So I'm going to go ahead and set my line equal to line width 3, and you can specify the alpha argument, which allows you to basically control how transparent the line is. So I can say alpha is equal to 0.5. And if I run that, now you can see we actually have a little bit more transparency on this line. So you can combine color, line width, and alpha in order to get the exact appearance that you want. One last thing to note here is for shorthand, you actually don't have to type in line width completely. You can just type in LW and it will still work just fine. Okay, so we talked about line width, color, and alpha. I'm going to go ahead and remove the alpha call. Now let's talk about line style. So I can type in line style. And line style, there's quite a few options and they're listed in your notebook, but it basically just defines the style of the line, such as a dashed line or a dotted line. For instance, if I pass in 2 dashes, I end up getting a dashed line. I'm just passing this in as a string. Or if I pass in a dash and then a period, I get this sort of dashed line. So dash point, and then there's a couple more options, such as colon, which gets me these smaller dashes here. And you can check out the Jupyter Notebook for this lecture to see what other options you have. And you can also do steps. However, I rarely use those. Most often I'll just either do a dash line, or if you just put in one dash, it's just a solid line. Okay, and just like with line width, you actually don't need to type in line style. You can just put ls, and it will end up working just the same. Okay, so we talked about line width and line style. Now let's talk about markers. So markers are going to be used when you have just a few data points. For instance, if we take a look at x as a reminder of what it is, we can see that x is just an array of, go ahead and check the length of x, of 11 points. Let's say I actually wanted to mark where those 11 points occurred on this plot. Well, I can specify marker as a new argument, it should be a comma, and then I can pass in a string. So there's lots of possible marker symbols, and they're listed in your notebook, but the most basic one and common one is just this lowercase o as a string. And there you can begin to see some dots that basically mark out each point on x versus y here. And there's a wide variety of markers available to you. They're all listed in your notebook, but just to show you a couple, you can do things such as plus signs, which don't show up too well here. You can do things such as little stars, like asterisk symbols. You can do things such as passing in these number codes. I'm going to make the line width a little thinner so you can actually see these markers here. Let's say we wanted to make these markers bigger. Well, you may have guessed that marker size is an argument. So you can go ahead and specify marker size, and essentially just 1 is the very small size. And then if we want to make it quite a bit larger, we can say 10. And here we can begin to see these kind of triangles begin to form. So let's go ahead and say just huge markers at 20. And then we can specify marker type here, 2. We can say plus, we get these pluses here, etc. So all these options are listed in the documentation, and more importantly, in your Jupyter Notebook. So there's so many different types of strings you can pass in as marker for marker codes. And if you really want to customize your markers, for instance, let's go ahead and put this back to lowercase o so we get these points here. I'm going to change this line width back to 1. There's actually quite a few options as far as specifying what the marker looks like. You can specify the marker face color, the marker edge width, and the marker edge color. So for instance, I'm going to go ahead and add these arguments in. So I'm just press comma enter for a new line, and I'm going to go ahead and say marker face color. And you can specify the marker face color. So that'll be the color inside of that circle. Let's go ahead and make it yellow and run this. And that changed the marker face color. Let's say I want to change the marker edge width. I can go ahead and edit that as well, make that a little thicker, such as 3. That makes it a little thicker. And let's say I actually want to specify the color of the marker edge. I can specify marker edge color. And let's go ahead and make that green. All right, so you can see there's a lot of customizability here, and there's a lot of options. If you want to see a bunch of examples of different options, you can go ahead and jump to the Jupyter Notebook for this lecture. I'm going to go ahead and do that now. Just going to go ahead and click on over. And if you see here under the Matplotlib concepts lecture, right now we're in this section line marker and line and marker styles. Here there's basically a figure where we did 12 by 6 on these subplots as far as figure size, and did a bunch of plots and edited the colors, the line widths, the line styles. And here's just a bunch of examples, so you can go ahead and read them out. And if you're looking for different possible marker symbols, they're all here as comments or line style types, etc. So there's a lot of different examples here that you can kind of copy and paste from or build your own knowledge off of. Finally, let's talk about control over axis appearance and plot range. And if we hop back over to our original notebook over here, we can go ahead and show how we can set the y limit and the x limit. I'm going to make this just a very simple plot again. Let's go ahead and just make this line width equal 2, and let's make line style equal some dash line. Okay, great. Let's say I only wanted to show the plot between 0 and 1 on the x-axis. Well, to do that, you can just call your axis, and then say set underscore xlim, and then you pass in a list with a lower bound and the upper bound. So we'll go from 0 to 1, and here we can see we've set the lower bound and upper bound of the x-axis. Now let's go ahead and do the same thing for the y limit. Just call your axis, and then say set underscore ylim, and as a list you pass in upper bound and lower bound. So lower bound at 0, comma, let's make the upper bound, let's go ahead and just put it at 2. And now we can see this plot. And notice as we zoom in, the plot looks more and more like a bunch of straight lines connecting points, which makes sense because we don't have as much detail since there's only 11 points. As we zoom out, we see more of a curved line. And we can fix that by getting more data points or by zooming out. All right, finally I want to hop back over real quick to the Matplotlib concepts lecture and talk about special plot types. There's lots and lots of many specialized plot types you can do with Matplotlib, such as bar plots, histograms, and scatter plots. Most of these plot types, we're actually going to use another visualization library called Seaborn, which is much better suited for these sort of statistical plotting methods. But just to show you that you can do this in Matplotlib, you can perform scatter plots, such as this. You can perform histograms using Matplotlib, or even things such as box plots. And here are some examples for you. Now, at the very bottom of your Jupyter Notebook for this lecture, you'll see a bunch of links for further reading, including the project webpage for Matplotlib. And one link I really like is all the way here, second to the bottom, this loria.fr. It's a really nice link. It's a Matplotlib tutorial. Hopefully you actually know quite a bit now by watching these 3 lectures that we just did. But what I really like about this link is that it's essentially just a reference code. So if you want to change colors and line widths, you can go ahead and check out this link. Just look at the figures and it will tell you how to set ticks, set tick labels, etc. Moving spines, adding legends. A lot of these points are actually in the other notebook for this lecture series called the Advanced Matplotlib notebook. We're not actually going to have a video lecture on those advanced topics for now because we're not going to use them too often throughout the course. In fact, we're mostly going to be using Seaborn throughout the course. Okay. Coming up next is a quick overview of the Matplotlib exercise, and then you'll have an overview of the solutions for that exercise. For now, go ahead and hold off on these special plot types and wait till we learn about using Seaborn, which is going to be much better equipped for these sort of beautiful statistical plots. Okay, thanks everyone, and I'll see you at the next lecture. Hello everyone, and welcome to the Matplotlib exercises overview lecture. In this lecture, we're going to quickly get an overview of the exercises for the Matplotlib lecture. Let's go ahead and jump to the Jupyter. Jupyter notebook called matplotlib exercises. This notebook is located under the Python for data visualization folder under the matplotlib folder. I'm going to go ahead and go to the notebook now. Okay, here I am at the notebook for matplotlib exercises. This is just going to be a simple task for reviewing some matplotlib. Take your time with these, since matplotlib can be tricky to understand at first if you're a true beginner in it. These are relatively simple plots, but just take your time, and a quick note, all the commands for plotting a figure should all go in the same cell. Separating the commands line by line into multiple cells may cause nothing to show up. So if you're using Jupyter Notebook, each exercise's cell code should all go into one cell. Throughout these exercises, you're going to be using the data defined in this cell right here, X, Y, and Z. And there's basically just 4 exercises. There's exercise 1, where you're going to be trying to recreate this figure right here, a simple one. Then exercise 2, you'll be working with an insert set into the axis here, and then plotting on it. And then exercise 3, you're going to do a similar task. Notice here, we're plotting X versus Z and X versus Y. And then here, we're also doing another subplot exercise. Okay, that's it for this little lecture here. Go ahead and get started, and in the next lecture, we're going to go ahead and go through the solutions. Thanks everyone, and I'll see you at the next lecture. Notebook to get started. Alright, here I am at the notebook for the matplotlib exercises. Set matplotlib inline. Now there's one more question, which is what command do you use if you aren't using a Jupyter notebook? And as a reminder, that would be plt.show at the end of all your plotting commands. Let's go ahead and start with exercise 1. We want to create a figure object called fig using plt.figure. Alright, so this is just the object-oriented method of using matplotlib, where we say fig is equal to plt.figure, and then we want to use add_axes to add a set of axes to this figure, and I'm going to go ahead and say ax is equal to fig.add_axes, and we actually get the position we wanted at, 0, 0, 1. And set matplotlib inline. Now there's one more question, which is what command do you use if you aren't using a Jupyter notebook? And as a reminder, that would be plt.show at the end of all your plotting commands. Let's go ahead and start with exercise 1. We want to create a figure object called fig using plt.figure. Alright, so this is just the object-oriented method of using matplotlib, where we say fig is equal to plt.figure, and then we want to use add_axes to add a set of axes to this figure, and I'm going to go ahead and say ax is equal to fig.add_axes, and we actually get the position we wanted at, 0, 0, 1, 1, and then finally I wanted to plot x comma y on that, and run this. Okay, looks like we have a good match here, and we want the labels and titles to match below. So if we go ahead and set that in, we want it to say set x label to be x, and then x.set y label to be y. And we also want to set the title and object. Plot two axes on it, x1 and x2. So the second one is located at 0.2. Great. Now continuing on with this exercise, what we want to do is plot both 0.2, 0.5, 0.2, 0.2. A same result here. Great. Now continuing on with this exercise, what we want to do is plot both x and y on both axes here. Let's go ahead and add that into the cell. So I'm going to say x1 plot xy and x2 dot plot xy. And here we have the same plot right here. If you wanted that to be red, you could have just added in the color argument red. You can just pass in a string, and now it will be red to match this lower plot. And then if you wanted to, you could have also added in the x labels and the y labels. Let's go ahead and move on to exercise 3, which was create the plot below by adding two axes to a figure object at these specific canvas points. All right, so not as much guidance now on exercise 3. First thing I want to do is create a figure object. So I'm going to say fig is equal to plt.figure. And then the next thing I want to do is begin to add those sets of axes. I'm going to say ax is equal to fig.addAxes. And we'll put them at the same locations that were requested at. And we'll say ax2 is equal to fig.add_axes. And we'll set these at 0.2, 0.5, 0.4, 0.4. All right, running that, looks like we get the same results. And then coming up next, we wanted to use the x, y, and z arrays to recreate this plot below. Let's go ahead and check out that plot below. I'm going to comment these out and bring this a little closer so we can see it. Let me zoom out a little bit. Okay, so it looks like we have a couple things going on here. In the outer plot, we have x versus z. Let's go ahead and add that in. So in the large plot, which is ax in our case, let's go ahead and plot x versus z. And I'm actually going to set the labels for that. So the x label, set x label, set that to x, and then x.set y label, set that to z. So again, this is the large plot. And now let's go ahead and talk about the insert plot. So if we take a look at what the insert plot has going on, it's going to be x by y over here. And it looks like the title is zoom. So I'm going to just go ahead and say xplot, xy, and then I'm going to set the title to be zoom. And I'm also going to go ahead and set those labels to be x, and then for the y to be y. And we're actually not quite finished yet. Let's go ahead and run this and see what difference we get. So note right now, I made a mistake. This should have been on the insert. So this should have been ax2 for all of these. Now let's go ahead and run this. And this is looking okay, but there's still a difference here. Notice on the zoom, the x and y limits. So x goes from 20 to 22. If we can match these up correctly. Plot xz. Let's go ahead and run this, see if we get everything looking okay. All right, not bad. It looks like the plot's call. So we'll go ahead and say 12.2. ls over here is equal to dash lines. And now we switched it and matched it. All right, that's it for the exercises for matplotlib. Data numbers such as 12, and the second number to be smaller. So dash lines. And now we switched it and matched it. All right, that's it for the exercises for matplotlib. Hopefully it really drilled in as far as the syntax for using object-oriented matplotlib. all you have to do is say, call the figure, add axes to the figure, and then plot on those axes. Or if you're using subplots, as in the last problem, call fig, axes to plt.subplots, and then iterate through those axes, or call using the array of axes to plot on each particular subplot. That's really all there is to it. Go ahead and review the solutions notebook in case any of this was unclear, or feel free to post a question to the Q&A forums. Thanks everyone, and I'll see you at the next lecture. Library, and it's built on top of matplotlib. So all that in order to get it installed onto your computer, you're going to have to use either conda install Seaborn if you're using the Anaconda distribution of Python, or if you install Python from some other source, you can also use pip install Seaborn, and just do that at either your command line or terminal. Let's go ahead and get a quick tour of the official website. I'm going to go ahead and go to Google and show you how to find the official documentation. Alright, here I am at Google. In order to find the link to the official documentation, since Seaborn
you take those decisions. We discussed about decisions related to location of the facilities, decision related to size of those facilities, decision related to mode of transportation, decision related to information system. So we discussed all these things. We also discussed that strategic decisions are long-term decisions, and you have to be very careful in making those long-term decisions, because changing those long-term decisions involve huge amount of cost. If I develop a factory in Uttarakhand, but tomorrow I feel that it is not very economical to have this factory in Uttarakhand, now I should have this factory in Sikkim. So you on your own can understand that this decision is a very expensive decision. Shifting the manufacturing base from Uttarakhand to Sikkim will involve huge amount of cost, and ultimately this cost will result into poor profitability of your supply chain. So you have to be very, very careful, but at the same time we want enough flexibility in our strategic decision making also, and for that purpose the role of analytics is going to be very, very important. Now let us discuss in this lecture another phases of the supply chain decision making, and the second phase, which is also known as tactical phase, is supply chain planning. So supply chain strategic decisions are at the top. That strategic decisions, when we come to a specific implementation part, you have supply chain planning, and finally when we move to execution of these things, it is the operational level decisions. So now we are at this level of supply chain decision phase, that is the planning phase. So here you develop a set of policies that govern your short-term operations. As I discussed, the scope of strategic decisions is long-term. The scope of planning decision is relatively short. So you develop a long-term roadmap. You have decided that I have to build a factory at Uttarakhand. Now, in how many years you are going to build, and in that 4 years of span, 5 years of span, or 3 years of span, you develop some kind of 6 months annual targets for yourself. That is the part of your set of policies for short-term operations. Then this is the planning phase is largely governed by the previous phase. Previous phase is your strategic management. So the planning phase is largely governed by the phase which is previous to it. So previous phase, that is the strategic phase, gives you the broad scope, and within that broad scope you have a 5-year planning, and from that 5-year planning you draw the annual budgets. So it is like that, you have one umbrella strategy, and within that you identify the scope for short-term objectives. So the configuration of planning is determined by the previous phases, and the starting point of the planning is very interesting. Now here the role of data comes. For these two things, I don't find much of the application of data-driven analysis. But now you see the starting point of planning is the forecast for the coming year, and the forecast, the demand forecast, is one very important part of the planning exercise. And here comes the role of data-driven analysis, data-driven decision making. That how are you doing the forecast? Normally we do forecast based on the previous year's data, but nowadays we require more predictive modeling. We require that type of analytics tools which can help us on the basis of some data which is not has happened so far but may come in the future. And that change in planning approach is only possible with the help of supply chain analytics. So this forecasting point of which is the starting point of your planning exercise requires the deep knowledge of data analytics. And there are a large number of forecasting methods. Many of you may already be aware that these forecasting methods like the very popular is time series analysis. The time series analysis is all based on my historical data, the previous year's data. But now we will see that how we can do predictive modeling, how can we do this analysis based on the future data. So that is the important part where data analytics will play a very handy tool for us. So the type of decisions which we take in the supply chain planning phase. So which market will be supplied from which location. So we had that picture where you have this kind of network. You have so many retailers and you have different wholesalers. So you take a decision that from which wholesaler to which retailer. These type of decisions are taken in the case of planning. Then what are the inventory levels? What are the inventory levels individual facilities are going to have? What will be the inventory level available with these wholesalers? What will be the inventory level with individual retailers? So far, you all must have observed that in our conventional setting, retailers are independent to take decisions about their inventory level. Wholesalers are independent to take decisions about their inventory level. But when we are talking of supply chain, we feel that the different parties, the different entities, different players involved in supply chain, they should not be independent in these types of decision makings. These types of decision makings which are affecting the total profitability of the supply chain. And therefore, the decisions related to inventory are not by the individuals. Rather, these are the planned decisions about the inventory that which stage will hold how much inventory. So that is again a very important supply chain planning decision we take. And this decision of planned build-up inventory is based on real-time data, which we have already discussed that what is the meaning of real-time data and how it flows into the supply chain. So that is a planning decision. Then subcontracting, backup locations, etc. Nowadays, we all know that all these activities of manufacturing, transportation, warehousing, retailing, etc. The time of fold is no longer there. You require different partners in this process of supply chain. From left to right, you need so many different partners. And when I'm talking of so many different partners, you many a times subcontract your various activities. Sometimes you may subcontract your manufacturing activities. Sometimes you can subcontract your transportation activities. Sometimes you can subcontract your warehousing activities, etc., etc., depending upon the nature, depending upon the abilities of your subcontractors, etc. So subcontracting and backup location, how much to subcontract, to whom to subcontract, and what type of products to be subcontract. All these things are very important, and decisions about these subcontracting activities is also very important planning activity. Then inventory policy we have already discussed. Then timing and size of market promotion, that is also important. You see, in supply chain, many of us may argue that this is more related to marketing and less to supply chain. To some extent, it is correct also that timing and size of market promotion is a more marketing decision. But your supply chain must ensure that yes, when there is a promotion, the product is available in the market. The point which I am trying to say that if Apple says that on 7th September 2016, iPhone 7 will be launched across the globe. iPhone 7 will be launched across the globe on 7th September. So now, when this campaign is starting, to popularize the launch of iPhone 7, my supply chain must ensure that iPhone 7 is available secretly, securely to all my global retailers. So that is a very important thing. And like in India, we have normally the movie releases on every Friday. Now, every Friday when a new movie starts or released, you need to ensure a supply chain that movie must reach to the respective cinema halls, to the respective theaters, wherever it has to be screened. And you need to ensure enough safety, security, that there should not be any kind of theft of the CDs or DVDs or the prints of the movie. And at the right time, it should be screened across all the theaters. So these are some of the points which are related to timing and size of market promotion. So you need to do promotion only in those areas where your supply chain can ensure timely availability of those products. And at what time the product will be available, accordingly you start the promotion. So timing and size of promotion should be very much in sync with your supply chain planning. If supply chain planning and timing and size of promotion are not in line with each other, you see the recent case of Reliance Jio also. So when Jio is launched, when Jio launch was announced, so their supply chain ensured that the Jio SIM card, Jio mobiles are available to all their distributors. So it is, though on prima facie, timing and size of market promotion looks more marketing area, but when we go deep into it, when we try to understand the crux of this statement, we will find that supply chain is very closely associated with this timing and size of market promotion. Then at the planning stage, though at the strategic level also, but at the planning level also, the demand uncertainty, we already discussed this in the third lecture. The exchange rates, when we are talking of global markets, the exchange rates, and therefore the third point which we discussed in the third lecture, that is the fluctuations in the cost. So that exchange rate, changes in the exchange rate, the fluctuations in the exchange rate may also result into the fluctuations of the cost of supply chain. Then competition over the time horizon. The competition is also changing over a period of time. Once upon a time, for American companies, American automobile companies, American electronic companies, Japanese companies used to be the big competitors. But if you see today's scenario, the scenario of 21st century, Chinese companies are big competitors for American as well as to Japanese companies also. You go to Japan, everywhere you will find made in China product. You go to America, you go to Walmart there, everywhere you will find made in China products. You come to India, you are very fortunate that you still find a lot of made in India products. But in America and Japan, both these countries are facing very tough competition from Chinese companies. So competition is changing over a period of time. So your supply chain planning should also keep an eye on the changing competition over a period of time. Competition is more related to the strategic decision, but since strategic decision, as I discussed earlier, are long-term decisions, and competition is changing very fast. Competition is changing very fast, and the new players, new products, product life cycles, all is getting reduced day by day, and therefore the issue of competition, the how to handle competition, this type of questions are coming more into picture in our planning phase of the supply chain. So strategic, you can take only once in a while decision with respect to competition, but daily how to change your supply chain planning. For that purpose, we need to take care of competition at the planning stage also. So these are the important decisions which we make in the planning phase of the supply chain. Then we come to the third level of decision phase, that is the operational decisions which we do in the supply chain. So these operational decisions are related to execution of the supply chain. So now we are finally coming into the implementation stage of the supply chain, and here, as is mentioned, the time horizon is very, very small. So the time horizon is very small. It is long term in case of your strategic, it is relatively small in case of planning, and it is very small, and it is as small as you can see weekly or even daily in some cases also. So if you are talking of, let's say, food supply chain, if you are talking of food supply chain, so the time horizon may be daily. If I'm talking of apparel supply chain, the time horizon may be weekly. So we can go up to that level of execution monitoring, that time horizon can be weekly or daily. You take the example of 7-Eleven, Japan. In that case, the supply chain operation time horizon may be few hours also, because they replenish their inventory 3 times a day. And when they are replenishing their inventory 3 times a day, so in fact, the time horizon for companies like 7-Eleven Japan is less than a day. It is just 4 to 5 hours. So here, actually, the time horizon is really very, very small. Then here, we take decisions regarding individual customer orders. Now, at this level, we started taking care of individual customers. That what are the requirements of that particular customer, what are the quantities required, where it is required. So all those things with respect to individual customer, you are taking care at this phase. And here also, the past data may certainly help us to take better decisions with respect to customer satisfaction, with respect to customer experience, with respect to our supply chain decisions, and so that you can make your individual customers more happy. Then here, our supply chain configuration and this decision making is governed by the planning phases. So this is a kind of hierarchical arrangement. Planning activities are fixed by the strategic nature, and operational are fixed by the planning phase of the supply chain. The goal is to implement the operating policies as effective as possible. So whatever you have decided, whatever quantitative as well as qualitative goals you have for your organization, you try to implement at the operational level with the maximum effectiveness. Then allocation orders to inventory or production, set order due dates, generate pickup list from a warehouse, allocate order to a particular shipment, set delivery schedules, place replenishment order. All these are the various types of supply chain operational issues which we handle in the operation. So day to day, if you talk of a supply chain officer or a supply chain manager, so on a day to day basis, week to week basis, hour to hour basis, these are the important jobs, these are the important activities which he or she performs in an organization. So that raising the intents, making the challans, making the invoices, delivering the products to a shipment, etc. So all these things are the part of our supply chain operation. And in a good organization, you have some standard operating procedures for all these things. That how do we have inventory replenishment policies, how do we have the delivery schedule channel, and all these things. And here, one interesting thing is that in operational level, you can work with less amount of flexibility, because the time horizon is very small. Here the time horizon is very small. Time horizon is a few hours or day or a week. So things may not change so fast within a day, and therefore the advantage is there that you do not require much of flexibility. And on the other way, you can also write that less uncertainty is there because of short time horizon. So that is a very positive sign for supply chain operation, and therefore the skills required, therefore the kind of exposure required at the operational level is much less than what we require at the planning at strategic level. Because at strategic and planning level, you require a bigger vision, and you need to handle bigger challenges. And because of the operational requirement, because of your day-to-day affair involvement, it is not expected that you also focus on the external issues. So the focus of strategic and planning, these two levels, is equally on internal as well as external environment of your supply chain. While operational people, they are more concerned with the day-to-day, with the internal environment of the organization. So that is how you can also understand the difference in scope of work of different phases of supply chain. So now, once we are clear with the different phases of supply chain decision making, now the next part of our discussion, which we will continue to the next 2 lectures also, that is about different ways in which you can study a supply chain. There are 2 very popular ways which are available in literature which can help us to study the supply chain, and these are, one is cycle view and another is push-pull view. Cycle view, that there are different stages in the supply chain. We have discussed in our all the classes earlier that you have a wholesaler, you have distributors, you have retailers, you have manufacturers, you have customers. So there are different stages, and the process is happening between 2 stages. If this is manufacturer, wholesaler, retailer, customer. So now the process is happening at any 2 stage, at manufacturer or wholesaler or retailer or customer, can be seen in this type of cyclic view. So you have a supplier supplying products to manufacturer, manufacturer giving products to distributor, distributor supplying products to retailer, and at retailer finally customer purchases the product. Now you see, this cyclic view conceptualizes a cycle at each of these interfaces. It conceptualizes a cycle at each of these interfaces. When customer is coming to retailer, this cycle is customer order cycle. When retailer is giving order to distributor, or otherwise also you can say that when distributor is supplying products to retailer, there is a replenishment cycle. The meaning is distributor is replenishing the stocks of retailer, fulfilling the requirement of retailer. When manufacturer is supplying products to distributor, this is the manufacturing cycle. Here manufacturer is making the products, producing the products, and supplying those products to the distributor. And when supplier is supplying raw material, components, sub-assemblies, parts to the manufacturer, this is the procurement cycle, that all these components etc. are procured by the manufacturer. So this way there are different types of cyclic activities which are happening. Now when we go for micro analysis, of all these cycles, you will find that in each of these cycles you have almost similar type of processes. Though here you have different names of these cycles: customer order cycle, replenishment cycle, manufacturing cycle, or procurement cycle. But actually the cycles are consist of various processes also, and we will see that all these cycles are consisting of similar type of processes. So that is very interesting. This E-cycle, as we mentioned, that E-cycle occurs at the interface of two successive stages, and these type of cycles we just discussed. And cycle view clearly defines processes involved and the owners of each process. It specifies the roles and responsibilities of each member. These are the different members: manufacturer, wholesaler, retailer, customer, etc. So within E-cycle, who are responsible for what type of activity? So that is what is specified in the cyclic view, and therefore cyclic view is very important for the proper distribution, proper understanding of roles and responsibilities of different members of this entire supply chain. The cyclic view is one way to look for the supply chain development, but there is one more way, that is push and pull view, and this will help us. This push and pull view will help us in developing the concept that what are the things in a supply chain can be done in anticipation and what are the things can be done in reaction in a supply chain. So this push and pull view is also very important for understanding the philosophy of supply chain. So we will continue with this push and pull view in our next lecture, and thank you very much. Till that, let's see. Processes may take place as push, and when it is happening, when you are shifting the boundary of push and pull from retailer to the distributor end, it means now retailer is not keeping the inventory in anticipation. Retailer will only be a source of contact to the customer, and whenever order comes, whenever a customer walks to the retailer's place, retailer will further pass this information to the distributor, and then distributor will supply the products to the customer. The example of Dell, when Dell was directly distributing products to the customer before 2006, right? In a complete supply chain, starting from the supplier source to the customer end, you have some of the processes which are known as push processes, and some of the processes which are known as pull processes. As the name represents, pull processes are those processes which are pulled, and customer is at this end pulling the products from the supply chain. So these are the pull processes. On the other hand, in case of push processes, the products are pushed to the supply chain. So demand is there or not there. These products are forced to the supply chain, and pull processes, as the name indicates, are there because demand is there. A customer wants these products, and customer wants these products, that therefore customer is pulling these products from the supply chain. So now the take of this push and pull for a supply chain manager is that processes which are happening as a result of pull processes are all reactive, because demand is there, therefore supply chain is trying to fulfill the demand. So these processes are reactive in nature. Push processes, because we feel that there will be demand, so these are in anticipation of demand. Demand has not occurred so far, but these are in anticipation of demand, and these processes are more proactive in nature. These are proactive in nature. You feel that demand is going to be there in the future, and therefore you are pushing products into the supply chain, that there will be a customer who will come and he will buy these products, so therefore I should maintain the sufficient inventory, sufficient stocks of these products. So in that anticipation, push processes are taking place. On the other hand, pull processes, you go to a restaurant, and when you go to a restaurant, the food will be ready only when you give an order. So preparation of food and serving the food to a customer is a good example of pull processes. While you go to a grocery store, you find so many chips, so many biscuits, so many other kind of food items are readily available. So these are push processes that shop owner feels that customers will come to me, and in anticipation of those demand, he is stocking the products. But normally you will find that in all supply chains, there are few processes which are done in anticipation. So these are push processes, and there are few processes which are done once the order has come. So these are pull processes. Now, for a manager, for a decision maker, with the help of the data, with the help of our supply chain analytics, the very important job with respect to push and pull is to identify the correct boundary of these processes. Where should we keep our boundary of push processes and pull processes, which is that point in the supply chain? And probably this is one of the most crucial decisions a manager has to make. And nowadays, with the help of data-driven analysis, with the help of data-driven decision-making processes, it is very important that you should have a dynamic type of push-pull boundary. We in the
old age system, in a supply chain, we always used to have a static push-pull boundary. But nowadays, because we are more into the real-time data-driven decision making, so it is quite possible that the boundary of push and pull processes may shift. So we will see with the help of an example that how this boundary of push and pull processes may shift with the help of new data which may be available to us over a period of time. Let us see a generic supply chain where we have manufacturer, a distributor, retailer, and customer. Now, the processes up to retailer are push processes, and only at the retailer end the processes are of the pull nature. When customer reaches the retailer, so retailer will give that product to the customer. So only this thing is happening as a pull process, and rest all these stages are bound by the push processes. When things are happening with push processes, all these places you will have very high level of inventory, because in anticipation you are stocking the products. It is quite possible that over the period of time, when you have more data available with you, you may shift the boundary of pull process to the distributor level, and only up to the distributor level processes may take place as push. And when it is happening, when you are shifting the boundary of push and pull from retailer to the distributor end, it means now retailer is not keeping the inventory in anticipation. Retailer will only be a source of contact to the customer, and whenever order comes, whenever a customer walks to the retailer's place, retailer will further pass this information to the distributor, and then distributor will supply the products to the customer. The example of Dell. When Dell was directly distributing products to the customer before 2006, so Dell was following this type of model where the push-pull boundary was at the dealer's end, distributor's end. But now, in the present system, when Dell is following the retail distribution, in that particular case, the boundary of push-pull is shifted to this case. So you can see the pre-2006, and this is present. So in the case of Dell, the boundary of push and pull has moved from the distributor to retailer from 2006 to now. So you have to be, and this is, by the way, based on all real-time data analysis. So this is a very good example that how your data analytics may help you to shift the boundaries of your push and pull processes. And you cannot be static all the time in present time scenario where you have a lot of competition, where you have so much into the market phase that every day things are changing. So push-pull view, as I told you, pull view is reactive, and push view in anticipation it is speculative, and the boundary of push and pull separates the push processes from the pull processes. So we have seen The role of boundary that before this and after this the processes are in anticipation and after this the processes are in reaction to the order of the customer. So push pull processes because
स्टार्टिंग होता है अगर सप्लाई चेन अगर आप स्टार्ट कर रहे हो अगर आप कोई एक नया चैनल आपने खोला है ठीक है आप सप्लाई कर रहे हो इसमें तो फिर इसमें क्या हो सकता है कि आप एंटिसिपेट ही कर सकते हो कि इतना चलेगा इतना नहीं चलेगा ये प्रोडक्ट बिकेगा इतना प्रोडक्ट नहीं बिकेगा लेकिन जो फुल बाउंड्री है वो तो रिएक्टिव है वो तो आप वो तो डिपेंडेंट है आपका पहला प्रोडक्ट जाएगा मार्केट में ड्रॉप हो जाता है सबको पता चल जाता है
another important part of the push and pull processes as we have just discussed here and it is further written in these slides that it also gives you an idea of who is going to share the maximum risk in your entire supply chain. You can understand very well. Those processes which are happening in reaction to the order, the risk in those stages are less. But those stages which are performing processes in anticipation or those stages which are having the push phenomena, the risk is high in those stages. So now it is a very important strategic decision in entire supply chain that which stage is going to have how much risk. And many a times you will see that manufacturer needs to keep maximum risk with itself. Sometime in some supply chains, very few supply chains you will find where distributors are keeping the maximum risk. But there will be very few supply chains like Walmart or something like that, where you will find that retailer is keeping the maximum risk. But in most of the cases, it is the manufacturer which is keeping the maximum risk because manufacturer has to prepare everything in anticipation of the order. But there are some very specific examples, particularly those manufacturers dealing in the industrial products like BHEL, making turbines, making transformers. These types of organizations, these types of manufacturers, they even do not keep inventory of those products. These companies start everything in the pull fashion. The example of BHEL, you will find that right from the beginning, right from the manufacturer's end, everything is happening in pull fashion. And very little is happening in anticipation. So some type of raw material procurement, some type of spare procurement, only those things may happen in push form, but rest of the things are happening entirely in the pull form. So those products which are industrial marketed or where the other word can be the unit value is very high. So those products where the unit value is very high, you normally find the entire processes are happening in the pull form. And but still, in this particular case also, the procurement of raw material, procurement of the spare parts and some of the components may happen in anticipation. So a little bit element of push will also be there here. You see, you cannot have the entire thing starting when the order comes to you. You cannot start going to a mine to get the iron ore for making a turbine only after the order comes. So you procure the steels, you procure the raw materials, you procure different types of alloys in anticipation that orders will come, and we need to have these materials ready with us whenever order comes. So you need to have a fine, though these are some of the guiding principles, but still, depending upon your own data, depending upon your own information, you will find a suitable boundary of push and pull in your supply chain. So that is very important, that where is the boundary of push and pull in your supply chain, because this, as I mentioned, that the relative proportion of push and pull can have an impact on supply chain performance. So it is very important. If this boundary is not properly selected, it may result in excessive inventory or it may result in stockouts. So our data, our analytics will help us to appropriately select the boundary that will give us better supply chain performance. Now another point which we will like to discuss in this session, that is about the competitive and supply chain strategies. You see, supply chain strategy should always support. Supply chain strategy is a type of functional strategy, and in an organization there are variety of functional strategies. So all those functional strategies should support the competitive strategy of the organization. Now what is the competitive strategy? The competitive strategy is the set of customers' need a firm seeks to satisfy through its products and services. Now the meaning is how differently a firm can fulfill the requirement of its customer over its competitors. I require some product for my transportation requirements. Now there are A, B, C, D, E, 5 different marketers offering different type of transportation solutions. Now what is that USP of A, what is that USP of B, what is that USP of C? That defines my competitive strategy. So each one of us, each marketer, each corporate, they look to provide some kind of different solution, some kind of a unique solution, the unique way to fulfill the requirement of the customer's need. Walmart is a very popular example, and in our supply chain class we use this example so often. The competitive strategy of Walmart is everyday low pricing. Everyday low pricing, that is the competitive strategy of Walmart. Means Walmart is famous. Walmart provides that you can get large number of products under single roof with the lowest possible price on a particular day. So that is the competitive strategy of the Walmart. So now the issue is that how my supply chain supports this competitive strategy, and then only the success of organization comes. So here we see that there are different types of functional strategies. You have product development strategy, you have marketing and sales strategy. These are the functional strategy, and then there is a supply chain strategy. Supply chain strategy should support my competitive strategy. It should be in sync with my competitive strategy. It should support my competitive strategy so that I can achieve what I want to. Now, supply chain strategy is
It determines the nature of material procurement, transportation, materials, manufacturing of products, creation of services, distribution, and it is also how consistency and support between supply chain strategy, competitive strategy, and other functional strategy. Earlier, we used to have different silos in organization. Silos means each one of us, if I'm in the marketing department, I normally use no communication with my product development department. If I'm in product development department, I used to have no communication with my production department. If I'm in the production department, I used to have no communication with my HR department. So we used to live in silos earlier. But nowadays, it is not possible to live in silos. We need to have a very strong integration of all functional strategies. Therefore, this value chain represents that right from the new product development to marketing, sales, to operations, to distribution, to services, all these things, all these functional areas need to be integrated, need to be supportive of each other. And finance, accounting, IT, human resource, etc. need to work as supporting to these major functional areas. So this is the value chain which links the supply chain with the business strategy of the organization. And therefore, we are very much concerned that what type of supply chain strategy we adopt so that the competitive strategy of my organization can be achieved. And for that purpose, we further talk of this strategic fit, where we should have a consistency between customer priorities of competitive strategy and our supply chain capabilities specified by supply chain strategy. Now, it is very, very important to understand that customer priorities, which is determining my competitive strategy, and supply chain capabilities, these things are determining my supply chain strategy. So my customer priorities, my ability to understand my customer priorities, that is the first important role which analytics will play. The data will help me to understand the priorities of my customer. And it is very simple to understand that over a period of time, customer priorities are changing. Customer priorities are no longer constant. I am living in India, but in India also, the priorities which we used to have about 20 years back or 30 years back, these are no longer the priority at the moment. Our priorities are totally changing. So priorities do change as we get more exposure, as we have better purchasing power, as we have access to latest technology, particularly IT, particularly internet, and so on. So all these things are helping me to change the customer priorities. Now, as a marketer, as a supply chain decision maker, if I am not able to capture the changing priorities of my customer, I will not be able to evolve dynamically my competitive strategy. So the first important role of our supply chain analytics, the data analytics part into the supply chain, is to identify the changing customer priorities, how things are changing. You see, when Japanese movement of quality started, at that time, the customer priorities shifted towards getting a quality product. And throughout the world, not only in India, customers started expecting to get Japanese qualities in their product. But over a period of time, almost all the manufacturers throughout the world, they had same technology, same management principles, and they were able to deliver almost competitive quality levels. Then came the Chinese invasion of low cost. And nowadays, customer expects that the quality of the product will be as good as Japanese product, but we need price as low as Chinese products. So priority all of a sudden is changing. And then priorities do change with respect to different market segments. So as you go from one market segment to another market segment, maybe on any variable, you will find that priorities are changing. Sometimes I'm purchasing a product only for my status, and sometimes I purchase a product for its functional utilities. So dynamically, I need to see what are the customer priorities. So this is very, very important to understand that these are the customer priorities which I'm getting with the help of my data support. The second is supply chain capabilities. What my supply chain capabilities are, what it can do. And you have the example of Maruti in India. Maruti in India is a very good example that how Maruti reached to tier 1, then to tier 2, and now it is reaching tier 3 cities also of the country. And therefore, the vast infrastructure, the large number of facilities created by Maruti is helping to a great extent to achieve the supply chain strategy of the Maruti. But there are many companies in the country, they have a supply chain strategy in their vision, but the supply chain capabilities are not developed accordingly. And therefore, you are not able to implement, you are not able to execute that supply chain strategy. So first thing is, we want to develop a strategic fit between business strategy, or you can say competitive strategy, which supply chain strategy must support. And the supply chain strategy, the exhibit of this strategy comes in the form of capabilities. Capabilities which we develop, these are the manifestation of supply chain strategy. How do we see that this is the supply chain strategy? So the capabilities which you are developing, these are actually the manifestation of the supply chain strategy. And this manifestation must match with the competitive priorities or customer needs which are continuously. So changing customer priorities are to be captured with the help of data. So this is the first use of data analytics. That data analytics will help us in regularly monitoring the competitive priorities. And you need a very good strategic fit between these two things. Then, just to simplify the same statement, we have this statement that competitive and supply chain strategies must have the same goal. It means many times it is possible that people may not understand the holistic nature of the organization. And when they do not understand the holistic nature, people at their own departmental level, at their own functional level, may develop the departmental and functional goals. So we are warning against these things, that the overall goal of the organization, which is the business goal or the competitive goal and the supply chain goal, must have same objective, must be same thing. And then we further warn that a company may fail because of a lack of strategic fit or because its processes and resources do not provide the capabilities to execute the desired strategy. So we need to see that what type of strategy we are developing and how the resources and processes support these strategies. Just to give you an example, because it is becoming very theoretical, so how our resources can provide the support to the competitive strategy. For that purpose, if I'm talking a very market intensive strategy, my supply chain strategy is market intensive. Now, when I'm saying that I want to develop a market intensive strategy, supply chain strategy, the meaning is that I want to open large number of facilities in almost all the corners of my market. So when I'm talking of market intensive strategy or the market dominance strategy, I should have large number of facilities. But then in a city like Delhi, I'm opening only 2 retailers. In a city like Mumbai, I'm opening 3 retailers. So this does not qualify to be the market dominance strategy. When I'm saying market dominance strategy, in a city like Delhi, there should be more than 50 retailers. In a city like Mumbai, there should be more than 30 retailers. Wherever I go in Mumbai, wherever I go in Delhi, wherever I go in Kolkata, I should have every corner with my retailer. And Patanjali is a very good recent example that how Patanjali is following this market dominance strategy. And for that purpose, wherever you go in even a small city, every street, every market, you will find distributors, retailers of Patanjali. But if they say that we are going to be the market dominant company, and in whole of the city you have only one distributor, one retailer, then probably your supply chain capabilities are not matching with your supply chain strategy. So whatever supply chain strategy you have, you need to develop the resources, you need to develop the capabilities in line of that. And this strategy that we should follow market dominance strategy, it should come from your competitive strategy. That my customer prefers those products which are closely available, which are nearly available. They do not want to put a lot of efforts in buying those products. And if that is so, I should go for market dominance strategy. And when I go for market dominance strategy, then I should have large number of stores, large number of retail outlets in a particular area. So all these things must be in sync. If it is there, then my supply chain strategy is in line with my competitive strategy. But I say that my customer follows the convenience way of purchasing. But even in that case, my supply chain is following the selective way of distribution. So my supply chain strategy is not in line with my competitive strategy. So the very first thing, we should understand the competitive priority, that what are the competitive priorities, and according to those competitive priorities, I must design my supply chain strategy, and according to supply chain strategy, I should develop my supply chain capability. So data analytics is the part which will help us in dynamically understanding the competitive priorities, and accordingly you can take all these decisions. The very good example of use of data analytics in developing the supply chain capability is almost all petroleum companies in our country. Earlier, we used to have very limited number of retail outlets of these petroleum companies, to which we call as petrol pumps. But now, over a period of time, with the help of available data, these companies realized that number of automobiles, number of cars, number of two-wheelers in the country is increasing exponentially, and therefore the requirement of petroleum products are going to increase. And then they realized that we should go for the market dominance strategy. And for that purpose, now you see almost in each street of the city, highways are filled with the petrol pumps of different types of companies. So the earlier very selective strategy was there, but now it is totally changed into the market dominance strategy. So this way, you can understand that how data analytics can help us in providing the required strategic fit between the competitive strategy and the supply chain strategy of an organization. Now, moving further into this discussion of supply chain strategy and the competitive strategy, we will see that it is a 3-step process. The first process is you need to understand the customer and supply chain uncertainties. So, as I'm saying that your customer is continuously changing its priorities, and so on, the capabilities of your supply chain also has a lot of uncertainties. Because in your supply chain, there are suppliers, vendors, different type of other members are there, and they all have some component of uncertainty associated with them. So, very first thing is to understand the customer and supply chain uncertainty. And to a large extent, data analytics may help us in resolving the issue of these uncertainties. You can have good modeling softwares we will discuss, and those things will help us in removing the customer and supply chain uncertainties. Then the second thing is to understand your own supply chain, the capabilities. These capabilities, what are these capabilities? So that is the second part. And third part, you need to link these supply chain capabilities with the customer and supply chain uncertainty. Whatever uncertainties you resolve, you should try to fulfill those things with the help of your supply chain capability. If you can do that, it means you have achieved the strategic fit. So here, today we close about this concept of strategic fit. In our next session, we will see with the help of some kind of modeling exercise that how this strategic fit is achieved, and that will give us, with help of some more practical examples, the usefulness of the data analytics in achieving the supply chain strategic fit with your competitive strategy. Thank you very much. Data analytics will help us to decide dynamically where to keep the boundary of push processes and pull processes in a supply chain environment. Now, the supply chain, as we discussed in our last lecture, must be in sync with the competitive strategy of the organization. And we discussed a 3-step procedure for achieving that strategic fit between the competitive strategy and the supply chain strategy. We also discussed that there are different types of functional strategies in a value chain, right from the new product development to the after sales services. There are various value addition components focusing more on the supply chain strategy, that what is the supply chain strategy and how we should develop with the help of data the robust supply chain strategy which can be fulfilling the supply chain capabilities, and those supply chain capabilities are in line with the customer requirements. And we yesterday in our last lecture discussed that those customer requirements are dynamic, and data analytics